I was spreading butter on my toast this morning, and it suddenly hit me. I have absolutely no idea how this stuff is actually made.
Well, I think most of us picture a wooden churn, right? Or maybe a quaint red barn.
Right, exactly. But digging into the sources we pulled for this deep dive, it turns out that Red Barn is actually a high-speed, precision-engineered fortress of stainless steel.
Oh, absolutely. It is way less like a kitchen and, well, much more like a high-tech refinery.
And our mission today is to track exactly how raw, chaotic milk gets transformed into those perfect identical yellow blocks sitting in your fridge.
Chaotic is definitely the right word there. Milk is a biological product, changes from cow to cow, season to season. The factory's job is to force that variability into a standardized global commodity using continuous processing.
So let's step inside a modern dairy processing plant. The tanker trucks have just arrived.
Yeah, and at reception, they essentially just use gravity and chain conveyors to get the liquid into the silos.
But the engineering really kicks in with clarification.
Right, because raw milk has microscopic sediment and impurities. To get those out, they use industrial clarifiers, which are basically high-speed centrifuges.
And we aren't talking about a salad spinner here. The specs say these machines are spinning at 6,000 times the force of gravity.
Which is intense but necessary. It relies entirely on the physics of density. Skim milk is heavier, about 1.035 grams per cubic centimeter, while the fat is lighter, around 0.93.
So that 6,000 G-force basically slams the heavier impurities against the outer wall.
Exactly. It ejects them instantly, leaving just the clean liquid.
Okay, so we've scrubbed the milk with physics, but now we have a consistency problem. Like one batch might be super fatty, another watery.
Which brings us to standardization.
Yes, this part was fascinating. They use inline density sensors, specifically near-infrared spectroscopy.
It is a mouthful, but it's a brilliant piece of technology. It's bouncing light off the milk to count the fat content in real time.
Just analyzing the chemistry on the fly.
Precisely. Based on that data, the system splits the milk using disc centrifuges. Imagine stacks of 24 or more discs spinning wildly to separate the heavy cream.
And then a computer automatically adjusts the valves to blend the green and skim back together to hit a precise target.
Usually targeting 35 to 40% fat for butter production.
It's amazing that it corrects the mixture instantly.
It absolutely has to. And once that composition is locked in, we move to a strict, non-negotiable safety stage, pasteurization.
Right, and this isn't just boiling a pot. They use plate heat exchangers.
Correct. Imagine hundreds of thin stainless steel plates creating separate channels. Hot water flows on one side, cream on the other.
So they exchange heat to kill pathogens without the fluids ever actually mixing.
Exactly. It ensures the product is completely safe while preserving the delicate flavor profile.
Okay, so we have safe, standardized cream. Now we move into the actual transformation, which really blew my mind.
Right, the old school batch churning is totally gone. Now we are looking at continuous butter making.
The mechanics here get pretty aggressive.
Very. The cream enters a high-speed beater system. It is subjected to extreme shear forces that break the membranes of the fat globules instantly.
The sources call this phase reversal. I love that term. You're literally flipping the physics of the liquid.
You are. Milk is an emulsion of fat floating in water. This high-speed beating forces the fat to clump together, trapping the water droplets inside instead.
So you switch from fat in water to water in fat. That's the butter.
And it happens in a split second. But temperature control is vital here in the texturizing stage. They condition the butter at exactly 55 to 60 degrees Fahrenheit.
Why that specific window?
It is all about the consumer experience, specifically spreadability. Process it too warm, the structure is weak. Too cold, it's brittle and crumbles on your toast.
So that 55 to 60 degree range is the sweet spot.
Yes, the exact engineering sweet spot to ensure the crystal structure is perfect.
It's wild how much effort goes into making sure it spreads smoothly. But how do they know they nailed it?
Quality control. And it is incredibly strict. The lab tracks very specific metrics. For one, fat content must be between 80 and 82%.
And moisture is the other big one. The notes highlighted 15 to 16%.
Absolutely. Over 16% moisture, you get soggy butter that leaks water. Under 15%, it's hard and dry.
I read they even use devices called penetrometers to physically measure the hardness of the blocks.
They do. But my favorite part is that despite all the lasers, centrifuges, and penetrometers, the final test is human.
Right. Technicians actually taste it to ensure the flavor is right. You just can't automate taste.
No, you can't. It is the final check on a process that turns a highly variable biological liquid into a reliable global staple.
It really puts breakfast in perspective. We started with raw milk and used 6,000 Gs of force, infrared light, and phase reversal just to make a sandwich.
It is a massive feat of logistics and mechanical engineering.
So here is a thought to leave you with. We spend so much energy standardizing nature, forcing it into perfect cubes. What other simple foods in your pantry are actually hiding that level of aggressive engineering?
Definitely something to think about next time you make toast.
For sure. Thanks for diving in with us.